All right, extinction. Is it a natural thing? Should species go extinct?
Yes.
Yes, they do. They should. They have, actually. And as is mentioned there, almost most of the organisms that have lived on Earth are no longer here. They have gone extinct. Okay, so this presents a little bit of a problem in defining whether or not something is going extinct because it's supposed to go extinct, or its time is up, so to speak, or is it something that we're causing to go extinct. So you have a no. Oh, it's not, nah. Hello, eraser. Okay, it's just gone down. So we have a natural, not a natural, but a background rate of extinction.
No.
And when we talk about background, that's something that's there already. What are the other places that we mentioned? Background variable was radiation. There's a certain amount of radiation that you naturally are exposed to every day, whether it's from the sun, radon, etc. Radioactive materials in the mantle of the earth besides radon. That is what's called background radiation. And so you also have what's known as a background rate of extinction. Okay? So that is going to be something that happens normally. It's hard to determine, like I said, it's hard to determine which is what in many cases, in many situations. So we have to look at the anthropogenic impact and what part or what role that is playing in the population numbers of this organism going down. So once that is done, we can establish what things are being driven to extinction, so to speak, by things that we do. Okay? So that's when we label them as being endangered species. All right, so the most common way we think of extinctions is the permanent kind, the kind where there's none left on Earth. Now this is something also that, depending upon the organism, can be kind of hard to determine. It's very hard to get a count on a lot of different organisms, and there are organisms that we think have gone extinct, but we were wrong. Anybody know the probably most popular common example of something we thought was extinct, but then they found one, and now we know that they're there still, that they have breeding populations, still endangered, but they're there around there. And anybody know what particular organism? And it's an interesting one because it has a good transitional organism we've seen between species that we know, or even the group of organisms that it's in. Is it a plant, animal, or, well, yeah, it's an animal, I'll tell you that. Any ideas? Nobody?
Is it here in Florida?
No, actually, they found it off the coast of South Africa. So that gives you a hint. It's off the coast. Huh? Sorry, that was not the right answer. Yeah. Dinosaurs are extinct. I'm pretty sure they haven't found another one. How about the coelacanth? Does anybody know what the coelacanth is?
The what?
It's a fish. Yeah, it's a fish. It's actually called a low-fin fish. Particularly those of you who had biology with Mr. Campbell should know that it represents a kind of a transition because the fins actually have appendages, bones in them, kind of like they're becoming legs and stuff. All right, well, that's a different story, but the point being is they thought it was extinct. For a long time they had fossil record of it, and then I believe it was around the 1920s or something, a fishing vessel just happened with a net, pulled in one of these, and the guy's looking like, well, that's weird, I've never seen a fish like that before, and they sent it to a museum, etc., and now we have the coelacanth, which does exist and is not actually extinct. So it's kind of hard to tell sometimes, but biological extinction is most commonly thought of extinction where that particular organism is gone from Earth altogether. There are other types of extinctions, though. Local extinctions within an ecosystem. This is when a population in a particular ecosystem's numbers are getting down to the point where it may no longer exist in that ecosystem. So And that's a bad thing. You know, we can't move organisms around all the time and take some out of here and put them in there. We've done that, and sometimes it does have good results, like putting wolves back into Yellowstone. But you know, in general, trying to change things to fix what we've done is not always the best way of doing things. So you have those type of things, local extinctions, that are of course more common as well. So that's a particular population in an ecosystem. And then you also have some other ones like genetic extinction. And that means that there are still surviving organisms, but their numbers have gotten so low that their gene pool is so small and limited and lacking in diversity that they're very prone to diseases and other types of things. And in general, biologists believe that, and genetic biologists believe that this species on its own, with no impact from people, does not have enough organisms in it to produce a viable population. That's going to go extinct anyway, even if you do everything you can to save it. And even if they're reproducing, you've got breeding pairs, they're still they're so genetically weak that they're just not going to make it. The cheetah is believed to be in this particular category, and the California condor is also in this area there. And so those are some examples of what genetic extinction is. I'm going to leave off commercial extinction because that's kind of something we talked about back in fishing, maybe remember. So what makes a species particularly vulnerable to extinction? As you might imagine, a few things like slow reproductive rates. Obviously, if it takes a long time for it to reproduce, we see this, of course, with a lot of top-level predators because we know that they have to keep their numbers small at the top of the ecological pyramid. Tigers, for example, reproduce like every 2 to 3 years. You know, so that's obviously when those numbers go down, it's going to have a slow rebound if you can bring it back. Limited tolerance ranges. That's good. That is actually one thing. Although that's a broad one, so that's not really what I was going for there. But I will give you the point for that group 3. It's a good answer and correct as well. Geographic range. So, and that actually also often is related to tolerance ranges because there's only certain parts of the world where the conditions are right for this organism. But if they're only naturally found in very small, very limited areas around the world, then they're going to be more liable to go extinct. You know, you're not going to be able to replenish their stocks from other places as well. Top of the food chain. Top of the food chain too yet. That, of course, is going to, there's fewer of them, they get more impact from toxins. They also, a lot of your top-level predators need a very broad range to get all their food from. They need large, wide open spaces, and we tend to do things to limit that, and therefore they become very susceptible to becoming extinct because of that as well. And then finally, if they have limited genetic diversity, this goes back to our genetic extinction. So if you've got a population that either because of its low numbers or just certain random, there's a lot of randomness to genetics, the way things come together, things called genetic drift and things, that they just happen to end up with a limited gene pool, they're not going to do very, very well and be more likely to go extinct. Another area that is of a lot of concern to population biologists and conservationists and everything are island species. And we don't really see this or think about this that much probably because we don't live on an island. But in many parts of the world, both in the Pacific and in the Caribbean, there's a lot of species, a lot of endangered species. There's a much higher rate of endangered species in those particular areas for a number of reasons. Some of them are kind of obvious in the fact that they're going to have a small geographic range. It's got not going to be a lot of places they can escape to reduce pressures on them, to find new food sources and things like that. Because islands have a limited number of environmental conditions, then these organisms oftentimes will be very specific niches, have specific things that they eat. We talked about this with different types of specialist versus generalist organisms. So a specialist is organisms that type of specific niches. Top of the food chain already. Did I put that twice? No, I just mentioned it before, but that's going to be one that included as well. So that one not so much. Let me say that you can have the top level predators anywhere, so that's not specific for island populations. But also with island populations, you've got storms, tsunamis, and things like that tend to have much greater impact, of course, on an island, and also. Because of the limited, their inability of the organisms to escape and go to a place of safety or a place where the change has not occurred that much, then they're going to be more vulnerable as well. So I think it's kind of obvious to assume that islands, ecosystems in general are more fragile. And we've seen a lot of endangerment as well as premature extinctions go on in those particular areas. Now, preserving biodiversity, that's what this is all about. The more organisms you have, the fewer number of populations of species that go extinct, the greater the biodiversity will be. That's why we call it preserving biodiversity. And you have a species-based approach, which is kind of the way it's been looked at a lot in the past. And this involves determining species that are endangered, doing things like the Endangered Species Act, which means if this species is present in a particular area, you can't develop that land, you can't possess these species, you certainly can't kill them, you can't transport them around. And so a number of regulations and stuff that's involved with protecting specific species that we have determined are endangered. And then you have the ecosystem approach, which is becoming more favorable and they're realizing more and more that this is really the way to go. But it's not always a practical thing to do because it's going to mean simply saying we're going to preserve land. We're going to take this land and we're not going to develop it. And in some cases, you might reclaim it. You might say, all right, this is kind of like a bad roadway or something like that. We're going to reroute it. We're just going to tear it up, reroute it around so it's not going through a biological hotspot, which we'll talk about what those are later, but going through as sensitive an area and trying to preserve the habitat that those endangered species are in. And there is also the flip side of this also is if you kind of like take your eye off the ball a little bit, you may end up, if you're not fully vested in just preserving the species that are endangered, some of them may go by the wayside. Like the cheetah, there may be nothing we can do about it. You guys, hopefully not, but you may see the end of wild populations of cheetahs in your lifetime. In the case of ecosystem-based approach, you'd say we'll just do what we can to preserve that cheetah's habitat. If they go extinct, that's unfortunately the way it is. So you can see how it can be hard decisions there, but in general, the ecosystem approach is the best because that's going to preserve habitat, that's going to reduce other species from going extinct as much, and therefore it is an ideal thing to do. Any questions about different types of extinction? And some of the things that make a species particularly susceptible, vulnerable to extinction. Alrighty.